Square root functions. When we're working with square root functions, it's a function whose rule contains a variable under the square root sign. So here we have examples of square root functions and non-examples. So an example of a square root function would be y equals the square root of x, y equals the square root of 2x plus 1, y equals 3 times the square root of x over 2 minus 6. All of these are examples because they have the square root sign associated with them. Non-examples would be, for instance, y equals x squared, y equals 2 over x plus 1, and y equals the square root of 3 times x. The reason it's not y equals 3 times x is because the square root sign is not under the x. Notice with the definition, it contains a variable under the square root sign. Something else to make note of is that when you recall that the square root of a negative number is not a real number, the domain x values of a square root function is restricted to numbers that make the value under the radical sign greater than or equal to 0. So remember, you cannot have, like for instance, a negative 3x under the radical sign because you cannot have negative numbers under your radical sign. And that's pretty much what this bullet point is saying right here. Excuse me. So let's look at finding what they ask for, the domain of the square root functions. So here we have for a, y equals the square root of 2x minus 1. You're just looking at what's under the radical sign. So here we have 2x minus 1. The first thing we have to do is we have to look at the expression under the radical sign, and it must be greater than or equal to 0. Why greater than or equal to 0? Because anything under radical sign cannot be negative. So the way we set this up is we'll rewrite what's under the radical sign. 2x minus 1 is greater than or equal to 0, just like it says here in the example. So then what we do is we go and we solve this inequality like normal. So we would add 1 to both sides to get 2x is greater than or equal to 1. Then you divide 2 to each side. So what you're going to end up with is x is greater than or equal to 1/2. So the domain of this square root function is going to be all real numbers greater than or equal to half. And this would be your answer. Let's look at the next example. Very similar, we solve it very similar to A. For B, we have y equals the square root of 3x minus 5. So what we do is we need to take the expression under the radical sign and have it be greater than or equal to 0. So what's under the radical sign is 3x minus 5, and we set that greater than or equal to 0. Again, we're going to solve this inequality. So we're going to add 5 to both sides. Then you're going to divide 3. So what you have here is x is greater than or equal to 5/3. So the domain of the square root function is all real numbers greater than or equal to 5/3. That's how you go about solving the domain for this. The next thing you're going to get into with this section is graphing square root functions, and here they're talking about translations of the graph f of x equals the square root of x. So in the left column here on this side, it says the graph f of x equals the square root of x plus c is a vertical translation of the graph f of x of the square root x. So what they did here is they have f of x equals the square root of x plus 4, square root of x plus 2, square root of x, and square root of x minus 1. These various graphs are showing you a square root function graph and then how it moves up the y-axis based on the adding of the values next to it. So notice the plus 4, it starts at 4, plus 2 starts at 2 on the y-axis. When you just have the square root of x, it starts at 0, and then square root of x minus 1 starts at -1. So this adding or subtracting after the square root is where that graph is going to fall on the y-axis. You also might see something like this, the graph f of x equals the square root of x minus a. This is a horizontal translation. Notice the difference between the two. This plus c is outside of the square root. X minus a is inside the square root. So this is vertical. When it's adding or subtracting under the radical, that's going to be a horizontal translation. So here we have f of x equals the square root of x plus 4. Notice now it's moving on the x-axis. So we start at, when you go ahead and solve this, you have to think of the opposite, starting at -4, because when you subtract 4 to each side, it starts at -4. Square root of x plus 2 starts here. Square root of x starts at 0. And then x minus 1 starts at 1. So the graph is translated a units right for a is greater than 0, and a units left for a is less than 0. It says here, if a square root function is given in one of these forms, you can graph the parent function, f of x equals the square root of x, and translate it vertically or horizontally. So let's go through an example here of graphing this square root function. So we have f of x equals 2 times the square root of x plus 3. Notice how we have this 2 out in front, and then we have this plus 3. In this particular situation, it's not going to be vertical or horizontal. And the reason for that is because, well, actually, it's going to be moving up vertically, this one, because of this plus 3 right here. So we can say moves vertically. So let's go through the steps to graph this. So we're first going to find the domain of the function. So what are we looking at under the radical sign? It's the square root of x. So we have x is greater than or equal to 0. So the expression under the radical sign must be greater than or equal to 0. So this is x is the expression under the radical sign is greater than or equal to 0. So the domain is the set of all real numbers greater than or equal to 0. And then what we're going to do is we're going to choose some x values greater than or equal to 0 to generate ordered pairs in order to graph this. I would use easy numbers working with square roots. So 0, 1, 4, they put here 6. Another number would be maybe even 9 because it's going to give you whole number answers when you're finding your y, your f of x. So we plugged in here x is 0, 1, 4, and 6. So the way you go about solving this is 2 times the square root, let me write it like this, 2 times the square root of 0 plus 3. The square root of 0 is 0, so it's really 2 times 0 plus 3. 2 times 0 is 0, 0 plus 3 is 3, so that's how they got 3 right there. For the next one, they did 2 times the square root of 1, 2 times the square root of 1 plus 3. The square root of 1 is 1, so 2 times 1 plus 3. 2 times 1 is 2, plus 3 is 5. Then they did 2 times the square root of 4 plus 3. The square root of 4 is 2, so 2 times 2 plus 3. So that's going to be 4 plus 3 is 7. The last one, 6, that's 2 times the square root of 6 plus 3. Now when you take the square root of 6, it's going to give you a decimal of 2.45. So you take 2 times 2.45 plus 3, round it to the nearest hundredth, so it's going to give you about 7.89. So plugging in my x's, getting my y's, now we have our ordered pair. So x is my x, here's my y, so the way this ordered pair works is 0, 3. So what I need to do is I need to graph these points and then connect them for the smooth curve for my square root function. So here is the graph that represents my square root function, f of x equals 2 times the square root of x plus 3. So here I have 0, go up to 3 and put a point. Then I have 1, 5. Then I go over to 4 and go up to 7. And then I move over to 6 and just estimate the best you can. 7.89 is closest to 8, so notice they estimated a point about 7.89. And then they connected the points to draw your line. So this is the graph of a square root function.